Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we're going to look at partial fraction decomposition with prime quadratic factors. So, with partial fraction decomposition, we break down a fraction with a common denominator into the sum or difference of more than one fraction. And today, our focus is on quadratic factors in the denominator. Now, if you remember in the last lecture, we talked about linear factors in the denominator. And in the numerator above each of those fractions, we had a general constant A, B, or C. Here, today, in dealing with quadratic factors in the denominator, we're going to have general expressions AX plus B, CX plus D, and so on above quadratic factors. So our goal here is to find A, B, C, and D. So we're going to look at an example. We have 5x squared minus 9x plus 19 divided by x minus 4 over x squared plus 5. Now in this case, we have a distinct quadratic factor. That's our x squared plus 5. And we have a distinct linear factor, which is our x minus 4. So this is already in its simplest form, that rational expression. So let's write our denominators of x minus 4 and x squared plus 5. As we said, x minus 4 is a linear factor, so we're going to put a general constant a in that numerator. And x squared plus 5 is a quadratic expression, and we're going to use bx plus c. So our goal here is to find a, b, and c. So we're going to multiply by our least common multiple of our denominators, which is x minus 4 times x squared plus 5. When we do that, the entire denominator on the left-hand side goes away, and we're left with 5x squared minus 9x plus 19. If we look at our a over x minus 4 and we multiply by that least common multiple, then the x minus 4 will go away, and we're left with a times x squared plus 5. In our second expression on the right-hand side, our x squared plus 5 will cancel, and we're left with what's in our numerator of bx plus c, and we're left with our x minus 4. So our next step is to go through on that right-hand side and multiply and collect like terms and write it in descending order. So if we distribute our a, we have ax squared plus 5a. If we use FOIL here, we're going to have bx squared minus 4bx plus cx minus 4c. And let's combine like terms. We have ax squared plus bx squared, so that's a plus b x squared. We have a negative 4b plus c times x. And then we have a constant term. We have 5a minus 4c. And now we're going to equate coefficients. So the coefficient of x squared on the right-hand side is a plus b, and on the left-hand side is 5. The coefficient of the x term on the right-hand side is negative 4b plus c, and it's negative 9 on the left-hand side. Then our constant is 5a minus 4c equals 19. Now this becomes a system of linear equations in 3 variables. And we can, if you need to refer back to the lecture on that to solve this, you can. But we're just going to tell you what the solutions are. Here, once you solve this system, A is going to be 3, B is going to be 2, and C is going to be negative 1. So our partial fraction decomposition is going to be 3 over x minus 4 plus 2x minus 1 over x squared plus 5. Let's look at another one. This is a situation where we have repeated quadratic factors. It's repeated because of this 2 here, and it's quadratic because of the 2 there. So this is in its simplest form. We're going to have x squared plus 4, and that's to the first power. And then we're going to have x squared plus 4 squared. Remember that when you have repeated factors, you have to start with the first power of that particular expression and go all the way to whatever the highest power is. And here it's 2 for us, so we're only going to have 2 terms. So we have quadratic factors, so we put in our numerator ax plus b and cx plus d. And we need to find a, b, c, and d. So let's multiply each term by x squared plus 4 quantity squared. In this case, we have our numerator x squared plus 2x plus 3 because the denominator totally cancels out. On the right hand side with our first term, in our denominator we have x squared plus 4 to the first power, where it's going to cancel out with one of those powers in our least common multiple, and it's going to leave x squared plus 4 to the first power. And then here in our second term on the right hand side, the denominator will totally cancel out and we're left with cx plus d. So again, let's work with this right hand side. Multiply everything out and put right in descending order. If we use FOIL, we have ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. So let's collect like terms and let's write this in descending order. We have ax cubed plus bx squared. We have 4ax and cx. So it's going to be 4a plus cx. Our constant, we have 4b plus d. And we're going to equate coefficients here. On the right hand side, we have a being the coefficient of x cubed. On our left hand side, we don't have an x cubed, so that means a is going to be 0. Here we have b as the coefficient of x squared, and on our left hand side we have 1. We have 4a plus c as the coefficient of x. On the left hand side we have 2. And we have 4b plus d as the constant on the right hand side, and on the left hand side we have 3. So knowing that a is 0, we're going to have 0 plus c equals 2. So c is 2. Knowing b is 1, we're going to have 4 times 1 is 4 plus d equals 3. So d is going to be negative 1. So our partial fraction decomposition, a is 0, so we don't write that term. B is 1, so we have 1 over x squared plus 4 plus c is 2. So we have 2x. D is negative 1, so there's 2x minus 1 times x squared plus 4 quantity squared. This is our partial fraction decomposition. So remember that Dr. LB is always in. Please come back for more math help.